Hello, hello, hello. Is anybody here from Optimism? Raise your hand. We need to talk. All right. Hello, everyone. Super happy to be here with you in Paris. I'm going to talk about minimum viable data availability on optimistic L2s. My name is Jerome. I run a company called Comef, and we have a super cool middleware suite called Alembic, not Mozambique. And we run on-chain games. That's our core business. We like to do games, and we like to do good tech for games. And also focus on retail applications that coming from Web 2 to Web 3. So this talk, I wanted to talk to you about three things. First, that when you do want to do innovative stuff on blockchain, it starts to be super gas heavy pretty fast because you're not relying on any standard contract. You are trying to innovate. You are trying to move fast and break things. L2s for this can be great, but they're still too expensive. And we are going to take a little deep dive on this topic specifically. We want to propose also solutions to solve this in the very short term. And eventually, if we still have time, we're going to talk about our implementation within the OP stack of an user experience and innovation-centric L2. So 3 years ago, in 2021, February, we started this first on-chain game, one of the first of its kind, along with Dark Forest roughly at the same time. It was a real-time strategy game, which I gave a presentation at ETCC4 and a live on-stage demo. This game still runs today, even though we don't create more content for this game at the moment. You can still play it, because it's living inside a blockchain called Polygon. In February 21, when we launched, it was super cheap. Doing an action in this game costed us 1/10 of a cent, and it went from 1/10 of a cent to 25 cents, 30 cents to do something in the game. The reason why it went so high in gas price and in price for the users was that the native token Matic pumped, and the average gas price went higher as well. Along the line, well, we had users that came from directly the Ethereum ecosystem, the Polygon ecosystem, and different EVM-based ecosystem with already a wallet, already something, and we wanted to try to onboard people from outside the Web3 world. So we did a lot of things to try to onboard them. We had a bad experience with funnel of acquisitions. We were paying for campaigns and realizing that installing a wallet was tough. Buying crypto was tough. Everything that Jesse before me explained, all of those things that you have to do before getting into a cool app. So we started to do a lot of research on how we can lower this cost on L2, notably, and also how we could use account abstraction on this. And my CTO will give a talk specifically on account abstraction tomorrow, if you want to get a better sense of it. So our conclusion during those tryouts, those 3 years of tryouts regarding onboarding people from Web 2 to Web 3 and building innovative stuff like games, was that when you have high gas prices, it's oftentimes because you have lots of cool applications regarding DeFi, and once you have those DeFi applications that are everywhere around your block space, it starts to hinder the innovation because it's getting more and more expensive for people to build something on testnet, deploy against test. And also, account abstraction is really something that can solve almost every user acquisition frictions that we have right now. But it's still limited to the cost of the execution layer we have underneath. Talking about the cost, so you've seen this kind of comparison with level 0, level 1, level 2 rollups and kind of nomenclature and a fight on words on what is a rollup, what is not a rollup, what is a L2, what is not a L2, and so on and so forth. Let's look at the cost metric here. Optimism and Arbitrum are two very good rollup, very popular. If you want to mint 1 million NFT, or saying otherwise, if you want to spend 115 billion gas, it will cost you roughly $21,000 to spend. That's kind of expensive, though. And you cannot really compare gas expenditure from one chain to the other, from one transaction to the others, because there are many moving pieces into that. But that's a good metric to have in mind. Minting 1 million NFT is $21,000 at July the 11th situation of gas price and Ethereum price. So we had many talks today about core concepts around the rollups. So I'm not going to spend too much time on this. I assume that you've been seeing this before. And Ethereum-centric rollup works with a data availability that's settled on Ethereum. So you write everything on Ethereum. The consensus comes from Ethereum, the settlement goes on Ethereum, and the execution stays on the rollup. That's the core concept. So practically speaking, this tree of transaction here happens on the rollup, are executed on the rollup, and then from time to time, you have a transaction on the L1 that takes all of those transactions, compress them a little bit, and update a rollup contract by saying the previous root of the state was that, and now the new root is that, and the transition between this previous root to the next root is all of those transactions. For reference, you can read in French the translation and incomplete guide to rollup by Vitalik on ethereumfriends.com. So let's focus a little bit on one of the core drivers for cost, data availability. Those are hard questions that data availability has to answer. Where is the history of what happened stored? Yeah, where is it? Is this place safe? Is this place a trusted one? Is this place a good one? And how available is this data? Like, if I want a sample, can I get one? Can I get it anytime? Like, what is the latency to get me a sample so I can verify that things are going all right? And also, how does putting those data in this L2 where it's stored, or this chain where it's stored, or this solution where it's stored, how does it impact the cost of executing on the L2? And eventually also, what happens if everything goes down? What happens if the sequencer goes down? What happens if all the RPC nodes are not responding anymore? What happens if you have to prove that the transaction was malicious? What happened? How can I rely to the L2 for this? How can I rely to the data availability for this as well? So in the Optimism stack, you have the difference between L2 execution fees and L1 data fee. That's what you pay when you pay a transaction on Optimism. And it's a similar concept that happened on Arbitrum and other optimistic chain. When you pay a transaction on an optimistic rollup, you say, what is the current state of the L2? Is there a lot of transaction? Is it crowded? Is it not crowded? And also, how crowded and how active is the L1? And most of the costs come from the L1 data fee. It turns out that Yaoqiu from Outlayer covered that in extenso in his talk of the 17th, so check it out. I'm not going to dive too much into this, but today you save very few on the data cost, and you save a lot on the execution cost. We have a plan at the Ethereum protocol level to introduce EIP 4844 and dunk sharding to greatly reduce this cost of L1 data and L2 data as general. But this improvement cannot come soon enough. Let's say we have a rollup called Rollmaps. It's an Ethereum-centric rollup, so it's putting all of its data history on the L1. It uses the L1 as a DA. Assume Rollmaps consume 2% of the L1 gas, which is roughly what some of the biggest optimistic rollup right now consume. How many copycats with the same time of activity of Rollmaps can be put on the L1 without EIP 4844 handling some of the throughputs? Well, very basic answer is like, okay, there's 100%, it's consumed 2%, we can do 50 of them. Well, it has moving pieces, like something will adjust itself, maybe there's optimization here and there, but still, soon enough, if we don't get good solutions on the data availability, L2s are going to eat the L1. They're also kind of bloating the state in some sense. So we should pay a lot of attention that if we cannot get dunk sharding and EIP 4844 soon enough, we will have to take decisions and be more aware of what we consume in terms of data. So another term of the L2 nomenclature is optimistic chain when we use data availability off-chain. And off-chain means not on Ethereum, not directly on the L1. So comparing a basic Ethereum rollup, centric, you have the data stored, everything lightly compressed is put on the L1. In case of an optimistic chain, you can go down to posting fixed size data pointer, saying, I'm doing my data availability there. Here's something you can verify, and here's what you should read and what you should find. So this concept of data availability committee, the person's keeping the data. In case of a basic Ethereum rollup, it's literally everyone, every node. If you run a node, you're keeping the data of Optimism. If you run a node, you're keeping the data of Arbitrum. If you run a node, you're not technically keeping the data of an optimistic chain because they are more mindful of where they store the data. Eventually, after EIP 4844, the data availability committee changed a little bit, and we can all converge on not keeping the data on Ethereum. Please don't bloat the state. How low can we go with a minimum security trade-off? So we tried for the past 6 months to overclock this, work on the Optimism Bedrock stack, and try to integrate a DAC, a Data Availability Committee, inside Optimism Bedrock. And we had different approach on this, different reference to what is the general philosophy of a blockchain, what have we heard, what have we learned over the years doing blockchain stuff. So with data availability here, we try to make it so that no one's really control them, like a blockchain, that eventually the infrastructure has no central point of failure. That's a good data availability. And also, like when we query this data availability layer, we should get a consistent response. Like there is a commonly agreed state of what's the data currently. And in a movement of making sure that this data availability layer can be decentralized and can be passed over to a community of users, anyone willing to take part in this data availability committee should be able to do so with reasonably low capital and technical effort and time efforts. So we ended up with this, and we are proud to introduce to you that we kind of overclocked the thing. So we are about to release a new L2 focused on user experiences and super low transaction fees called Muster, as in we should all get together. And our benchmark for this layer is that we can spill 115 billion gas and 1 million mints for about $400 consistently. So that's a huge improvement, and we are super glad to share that with you today. We would love to tell you more about it. So here's the min-maxing approach that we had. Regarding where is the L2 stored, the L2 data stored, we are looking at several different solutions. It's very modular and very easy to modify and improve. We are notably looking at solutions like Swarm, which Swarm was the initial storage layer of Ethereum in the early days of the Ethereum protocol. And it turns out it can be used for some of the data availability problems that we face today. And Swarm is 5,000 nodes, so it's kind of a decentralized network as its own. The data itself, if the data availability committee is done right, is very good. It can be staying there forever. It can be replaced, potentially always. Like, it's a good data availability layer because you have solutions made for that. When it comes to impacts on the L2, it's kind of minimum. It depends on how extreme you are into keeping the data, how many replication you want, but it can be really minimum and still very available. And if the DAC is online, but the L2 goes wrong, well, it's as good or as bad as Optimism, depending if you see the bottle half full or half empty. So if you're interested to talk to us about that, you can meet us at our booth. We have one upstairs. If you want to hop into the testnet, it's up and running. You can try it. If you want to get a deeper dive on the code, we're happy to share and give you access and let you review. For us to open source this code and get community reviewed, we needed to have a couple of PR merged on the Optimism side. And it turns out 3 hours ago they started to merge it. So thank you, Optimism. We are very happy to be part of the community now. Well, that's all right. That's what I had to share with you. Super happy to have you in Paris again. And I think we have 1 more minute to take some questions if you have some. Any questions? All right, then. See you later. Thank you so much.